Hi students, welcome back to Wisdom Academy YouTube channel. In the previous lecture, you have learnt about motion chapter. I have told what is motion, what is uniform and what is non-uniform motion. I told you what is the difference between distance, displacement, speed, velocity, what is acceleration, and then I also told you what are the different equations of motion. We derived those equations of motion graphically. The three equations of motion were V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. In today's lecture, we are going to start the second chapter of physics, that is force and laws of motion. So, laws of motion was given by Newton, and there were three laws of motion. So, Newton gave first law, the second law, and the third law. So, we are going to see all these laws in detail today. Before that, you should know what is a force. So, force, as we have seen from our junior classes, it is a push or a pull. So when you are pushing something or you are trying to pull it, that is known as force. Does not mean that when you are applying a force, the object needs to move. It is also possible that something is kept on the ground and you are trying to move it by applying a force and you are unable to move it. That does not mean that you have not applied the force. In that case also you have applied the force. Maybe what force you have applied is not sufficient to move it. So force, when you're trying to push something or you're trying to pull something, that action is known as force. Force is of mainly two types. One thing is balanced force and another thing is unbalanced force. So balanced and unbalanced force. So you will learn in the later part of the chapter that SI unit of force is Newton. How it comes and what is that we will discuss when we reach that part. So first we will talk about what is a balanced force and what is an unbalanced force. So suppose there is an object kept on the surface and you are applying a force on it. Let that force what you are applying be 100 Newton. Will the object move or not? Yeah, it may move. If suppose it is strong enough to move it, the body starts moving in this direction, isn't it? Now, in the same object, when there was 100 Newton force applied, what I am doing? I am applying the same 100 Newton force from this direction. Now, will the object move or not? It will definitely not move. So, this condition is called as unbalanced force. It is called as unbalanced force, and this condition is known as balanced force. So how to define that? Balanced force is a condition when equal and opposite forces are applied on a body, and in the case of balanced force the body does not move, whereas in the case of unbalanced force unequal forces are applied and the body tends to move in the direction in which the higher force is applied. For example, there is an object like this and you are applying two forces. One is 100 Newton in this direction and another one is 20 Newton in this direction. So will the object move? Yes. In which direction? In this direction, because 100 is more than 20. And with what force it will move? That net force will always be equal to higher force minus lower force, that is 100 minus 20. So it will move with a net force of 80 Newton. So this is the concept of balanced and unbalanced force. Now we are going to start one by one the laws of motion. So the first law of motion, the first law of motion. It's a very simple law. What it states that any object which is in a state of rest, which is in a state of rest or uniform motion, any object in state of rest or uniform motion will remain in the same state, will remain in the same state, until or unless an external unbalanced force acts on it. An external unbalanced force acts on it. This is the definition of Newton's first law of motion. It states that any object which is in a state of rest or in a state of uniform motion will remain in the same state until or unless an external unbalanced force acts on it. It means if there is any object kept on the ground, until you try to move the object, until you apply any force on it, actually unbalanced force on it. Someone can say, sir, I will apply force equal on both direction, it will not move. That's why I'm saying unbalanced force. So until or unless an unbalanced force is applied on it, the body will not move by itself. Someone can say, sir, what if an earthquake comes? What if a huge wind comes? Even the earthquake or the wind is a kind of force only. So until or unless an external force is active on a body, the body tends to remain in the state of rest or in a state of uniform motion. This is known as Newton's first law of motion. It is also known as law of inertia. It is also known as law of inertia. So what is the meaning of the word inertia? Inertia, it means the inability of an object. What is inertia? It is the inability of an object, to change its state, of rest or uniform motion, So if a body is in rest, it wants to be in rest. It does not want to come to a state of motion. Or if an object is in motion, it wants to be in motion. It does not want to come to rest. So inability of the object to change its state of rest or motion is known as inertia. So it is very similar to what first law of motion is, right? That the object will remain in rest or in motion until or unless force acts on it. Same way, inertia, it is the inability of an object to change its state of rest or motion. Now suppose I have an object here. An object is of 2 kg mass, right? And I have another object here. This object is of 5 kg mass. Now, if we apply a force on it, I apply a force of 10 Newton. This 10 Newton force may move this, but same 10 Newton force may not be able to move this. So the inability of this body is higher than this body. So what I am coming to say by this statement is that inertia is a factor of mass, or inertia depends on mass. So you can make a note of this. It's a very important thing that inertia depends on mass. So a body with higher mass will have higher inertia compared to a body with lower mass. So in the examinations, how they ask this question? They ask that if there are 2 balls made up of wood and iron of same size, will the both body have same inertia or different inertia? Obviously it will have different inertia. The object made by iron will have higher inertia compared to wood because iron is more heavier than wood. So remember that inertia is something which depends upon the mass of the object. So this is about the first law of motion. Let us once again revise that. It states that any object which is in a state of rest or in a state of uniform motion will remain in the same state until or unless an external unbalanced force acts on it. Now I said you, inertia also, it is the inability of an object to change its state of rest or motion. And I gave you example, and I also told you inertia depends upon mass. Now inertia is also of 3 types. Let us see what are those 3 types. So inertia is of 3 types, that is inertia of rest, inertia of motion, and inertia of direction. Inertia of rest, inertia of motion, and inertia of direction. Let us see one by one what is inertia of rest, what is inertia of motion, and what is inertia of direction. So let us see what is inertia of rest, motion, and direction. So inertia of rest means an object which is tending to be at rest and suddenly brought into a condition of motion. For example, when you are sitting on a bus and the bus is at rest, bus suddenly starts moving, what happens? We feel a jerk in the backward direction. That jerk comes in the backward direction because the lower part of your body is attached to the seat and everything is in rest. The moment the body starts moving suddenly, the lower part start moving, but the upper part is giving some opposition to that. That is the reason you get a jerk in the backward direction. Same way, inertia of motion is the inability of the body to change its state of motion. So for example, if the bus is moving and the body has got habituated to it and your full body is moving along with the bus, suddenly the driver applies the brake. When the driver applies the brake, the lower part of the body, which was in a state of motion, suddenly come to rest. Upper part of the body will give an opposition towards it also, and we tend to move like this in the front direction. So our movement in the front direction when the brake is applied of a bus is an example of inertia of motion. Inertia of direction is the inability of the body to accept a change in direction. Suppose you're sitting in a bus again and the bus is taking a turn. Have you seen when the bus takes a turn, our body starts to move like this in one angle? That happens because of inertia of direction. There can be many other examples of this inertia of rest, motion and direction. For example, I have a cloth and this cloth is having some dust. What we do to remove this dust in the cloth? We give a beating to it by a stick. So when we beat the cloth by a stick, what will happen? The cloth comes to motion suddenly, but these particles which are attached to it does not come to motion immediately. So they tend to fall down. For example, one more example can be, sometimes you would have seen on a tablecloth, this you have seen in some magic shows, that in the table there are some vessels kept, and the magician or that activist, he suddenly takes out this cloth without making all these things to fall down. It remains on the table itself and the cloth is taken out. That is also an example of inertia of rest. So these are some examples which can tell about inertia of rest, motion and direction. So I hope you have got some idea about what is inertia of rest, inertia of motion, inertia of direction. Now let us see the second law of motion. But before I start talking about second law of motion, I must tell you what is momentum. There is one new term coming as momentum. What is momentum? Momentum is a physical quantity. It is a physical quantity, which is a product quantity, which is the product of mass and velocity. So when you multiply mass and velocity, you get a quantity known as momentum. So what is momentum? It is a product of mass and velocity. It is denoted by small p. So small p is equal to m into v. So mass into velocity is known as momentum. So mass SI unit is kg, velocity SI unit is meter per second. So SI unit of momentum would be kg meter per second, or it is also written like this: kg meter s power minus 1. So kg meter per second. This is how we represent momentum. So what is momentum? It is the product of mass and velocity. So I told about momentum to you because our second law of motion is purely based upon that. So what is second law of motion? Newton's second law of motion. Please make the note of this because many students will forget this statement generally. So make a proper note of it. And what is second law of motion? It states that rate of change of momentum is directly proportional to the applied unbalanced force. So what is the second law of motion? It states that rate of change of momentum is directly proportional to the applied unbalanced force. So now let us break it and understand it. First, what is change in momentum? Change in momentum will be equal to final momentum minus initial momentum. So final momentum minus initial momentum. That will give me what? That will give me the change in momentum. And whenever this word rate comes, rate of something, that means it is divided by time. So rate of change of momentum means final momentum minus initial momentum by time. So this term is proportional to the force applied. So the force applied is proportional to rate of change of momentum. So I can write like this: F is proportional to what is final momentum? Mass into final velocity minus initial momentum, mass into initial velocity. Already have seen the concept of initial velocity and final velocity in the previous chapter, divided by time taken. Now this I can write further as F is proportional to, if I take m common, it will be V minus U by T. Now what is V minus U by T? You have seen in the previous class. It is acceleration. So I can write F is proportional to mass into acceleration. To remove the sign of proportionality, I have to add a constant, and that constant is K, small k, m, a. It was found experimentally that the value of K is equal to 1. It was found experimentally that K is equal to 1. So what I get? I get F is equal to ma. And this is known as Newton's second law of motion. That is, force is equal to mass into acceleration. In many places, you would have seen that the second law of motion is F is equal to ma. You should not remember in this way. Otherwise, what will happen? You will forget this derivation or this the relation. Rate of change of momentum is directly proportional to the applied unbalanced force. And if you solve this, at the end you will get F is equal to m into a. Now what is mass? Mass is in kg. What is acceleration? It is in meter per second square. This is the SI unit of force. So what is the SI unit of force? SI unit of force is kg meter per second square. Kg meter per second square. And this kg meter per second square is also known as Newton. A smaller unit is Newton. Since Newton found it, that's why it is called as Newton. So force SI unit is Newton. I already told you that I will talk about SI unit of force in the coming session. So now this is the thing. SI unit of force is Newton. So what we have understood? We have seen Newton's second law of motion. It states that rate of change of momentum is directly proportional to the applied unbalanced force. So in today's class, whatever we have seen what is force. It is the push or a pull. Then we have seen what is unbalanced force and balanced force. Then I told you about Newton's first law of motion, and I said you first law of motion is law of inertia. What is inertia? I told you, and what are the different types of inertia also I told you. Then I told you what is momentum. I found the mathematical expression of momentum, and then I derived the second law of motion. And second law of motion, it states that rate of change of momentum is directly proportional to the applied unbalanced force. And after solving this whole thing, I get finally F is equal to ma. I hope you have understood whatever I have taught in today's class. For any doubts and clarification, please comment in the comment section, or you can even ask me in the regular class. So with this, I am ending today's session. I hope you have liked it. Please like, share and subscribe our channel. Thank you.